Okay, welcome everybody. Hello, my name is Adam Keller. I am a developer advocate on the containers service team here at AWS, and welcome to our third week of containers from the couch. In case you missed it, we started 2 weeks ago. We worked on, went through ECS workshop, did some really cool stuff with ECS, deployed a stateful workload, did some cluster auto scaling, did just a lot of really fun stuff. And then last week we went through EKS workshop where Brent led us through a lot of really great stuff there. This week we're going to mix it up a little bit and we may take bits and pieces and go out of order. And for today, one thing that we talk about. Last week, Brent, you had mentioned day two, right? So day one is I need to get a container up and running. Hey, this is fantastic. But now, how do I know that my container is healthy? How do I know that it's doing what I expect it to do? So that leads us into the topic of health checks and how to ensure that your service is healthy. So I'm going to pass it to Brent to do an introduction and then go ahead and lead the way.
Awesome. Thanks, Adam. Yeah, so health checks. That's something that I think some people tend to overlook. And what I wanted to go through today is let's take a look at, really simple health checks, how to get them set up, and how to then make them work for you. So we're actually going to look at a couple of different styles of health checks. One is uh, a liveness probe, and the other one is a readiness probe. And this is all in the context of Kubernetes. So we're going to be using EKS, but you don't have to. This isn't EKS specific, so this works on every Kubernetes installation. It's just very, very generic Kubernetes information. So definitely stick with us. And if you have any questions in the chat, feel free to toss them in there and we'll try and address them as they come up. All right, let's dive into the workshop. So let's review real quick where we are with things. We started last week doing EKS workshop. And then in fact, Adam, could you swap screens over to the Cloud9 view?
Yes. Thank you.
No problem. So we started off with EKS Workshop. We went through, we built our cluster, we deployed some applications, then we templated them with Helm, and on Thursday we then did a cluster upgrade. So since then, I've actually erased the cluster and rebuilt it and got it caught back up to where we were, where we had Helm installed. So let's take a look real quick and let's just see what we have. If I cube control get services, I can see real quick the front end service has a load balancer. And if we go visit that URL, you see that our application is fully deployed, fully redundant. We have our one front end and our two back end microservices all running, in every availability zone. So we're good to go. So let's then talk about what a health check is. And real quick, Adam, like, what do you think? What is a health check, just in the most basic sense?
Yeah, I mean, when I think of a health check, it's a way to make sure that my service or my container, whatever it is that's running, that it's actually healthy and doing what I expect it to do.
Yeah, exactly. That's a great answer. There's a lot of people who they'll build a lot of logic into their health check. And if we were to look at our application, the application that we deployed and the one that we're going to poke at the most is the Node.js app, but they're all kind of built the same way. Our application just returns a simple response to a health check URL endpoint. So we have /health, and if curl /health or just address it with a get in any way, then you get back okay. So that's the most basic health check I can think of. And what does that tell us? That tells us that the process itself is still alive and it's still responding. So I'm able to know my process is good to go. Now, some people will take that and they'll extend it and they'll be like, okay, well, I know that my process needs to be able to talk to database XYZ and needs to be able to perform some kind of query, and it needs to be able to talk to these other backend services and so on and so forth. I'm not saying never test for those things, but I am saying don't make that your health check, because what'll happen, like let's say that you've done that and that's your health check. What happens then when your database goes down? Well, at that point, your health check starts to fail. And then the orchestrator starts to respond accordingly. So, Adam, what do you think the orchestrator is going to do when your health check is failing?
Yeah, I was so I was thinking like call on me, ooh ooh ooh. So thank you for that. But yeah, so what's going to happen is the orchestrator sees these services aren't healthy, so it's going to restart them, and then the new ones are going to come up, and granted, it most likely that database is still down or not responsive, so it's going to keep restarting and keep restarting,
Yeah,
basically.
exactly. So while I'm not completely opposed to having a check that you might do manually or you might do through some other automation to check the full, depth of dependencies, um, don't make that your health check, because you'll just end up creating a lot of churn unnecessarily in your orchestrator, having all of those rights as new applications come up that has to be written into the database. It'll start putting a ton of pressure on whatever your data store is for your orchestrator. In the Kubernetes case, that's etcd. So we want to try and avoid that if, when it's unnecessary, and we want to try and avoid churning our containers for no good reason. So let's take a look real quick then at what it means to build health checks into our containers. So we're going to talk about liveness probes, and we're going to talk about readiness probes, and we're going to take a look at each of those. So the first one, the liveness probe, this is what I think most people think of when they think of a health check. So let's just go ahead and build that, and then we'll look at it in terms of building and using our health check. So what I'm doing here is I'm building a deployment or a pod definition. This is just to demonstrate the health check, demonstrate the liveness functionality, and we're going to deploy the same Node.js application, but we're not going to do this right now to the existing application. So we're going to go ahead and kube control apply this liveness app definition, and it's just going to deploy a pod, but the pod includes our health check. Remember I said we curl /health, and that would tell us whether or not things are healthy. So that's all we're going to do here. So once we have that pod up, if we describe the pod, then we can see that it is ready, it's initialized, it's all good to go. So while we're at it, let's kube control get pods. And we're paying attention to the liveness app. It's been up for 43 seconds. And describe, you see our 52 seconds ago and then 51 seconds ago, we started the container. So we're good to go. Now what we're going to do is we're going to kill the process that would be responding on /health. So we're going to exec into our pod, the liveness app pod, and then the double dash here is a bashism for end the bash command. So everything that follows that is just going to get passed into the command itself. So we're going to pass in to our container basically that we're going to run bin kill with a sig user one process ID number one. So we're going to send a kill or a sig user one to PID number one, which is our Node.js PID. What do you think that's going to do?
Well, my guess is that the our service is not going to respond, causing it to go unhealthy.
Bingo. Yeah. So when we do this, we just sent the signal, and now if we describe the pod again, you see that we have a message: Liveness probe failed. Getting our address port 3000/health, request canceled. And if we do it again, um, we see that liveness failed. The container is going to be restarted. We do it again. It hasn't been quite enough time yet, so let's give it a few more seconds, and let's also do get pod. We don't have, so this restarts column, we've never really pointed that out before, but what we should see eventually, oh, there it is. So we should see that we'll eventually have a restart of this pod. And so that's the count of how many restarts we've had for that pod. And if we describe again, now we see there's our original liveness probe failed. Then we see the message that it will be restarted. That's where we left off. And then we see pulling successful, created, and started. And now we're back up and running again. So the orchestrator responded to the failed liveness by replacing that pod with a new pod. And so now we're back up and running again.
Now,
So that's,
I
go ahead.
I wanted to ask, and this is kind of a little lead in here, but so that's cool. You basically, we were able to see that we health checked our pod. Our service failed. The health check recognized that and restarted it. But maybe I'm going too fast here. But what happens when I that's great and all, but I need to wait a certain amount of time before my service can actually register as healthy
Ah,
on
okay.
startup.
So yeah, you are getting into then what the next function actually is. So there's responding to the health check, which should mean, hey, you're healthy. And when it comes up, it should almost immediately be respond. But there are situations where you might want to, for example, delay that. Don't take traffic until I'm fully ready to go. Or it might even be, let's say, for example, that you've been given a large job. And until you finished that job, you can't continue forward accepting additional jobs. So, in that situation, you want to stop receiving traffic. So, you're not unhealthy, but you don't want to get more traffic yet until you're ready for it again. And by the way, what did I just say? You're ready for it again? That is a readiness probe. So, a readiness probe is a different kind of health check. And with this probe, what we're doing is we're saying my pod is either ready or it's not ready based on the output of this readiness probe. And the difference, the way we react, the way the orchestrator reacts to that status is we send traffic or we don't. And if we're not ready, don't send traffic. If we are ready, send the traffic. But what we don't do is we don't restart the pod. So if you're not ready, you aren't going to get restarted. It just implies that there will come a point where you will be ready. And once you're ready again, we'll send you more traffic again. So let's deploy an app that uses a readiness probe. So in this particular case, what we're doing is we're going to build a deployment. This is just going to use the Alpine image, and we're going to touch a file, and then our readiness probe is just going to cap that file. And as long as it's capable of doing that, the pod's going to be considered ready. So let's go ahead and apply this. The deployment has been created. At this point, we should have 3 pods. They're not quite ready, but Now they are. So let's describe and grep for just replicas. This is what we care about out of the describe. You see that we desire three. We have three that are updated, three total, three available, zero unavailable. Unavailable would be a pod that we don't continue to send traffic to, right? If it goes unavailable, it's not ready. It's not ready, don't send it traffic. So let's introduce a failure. So let's grab one of these pod IDs and kube control exec into it. By the way, the workshop shows IT. I don't know if it's still this way, but I do TI because in Docker world that used to actually make a difference with sending control signals. TI, it would let you control C and stuff, and IT it would. Okay, so once I'm in here, I want to execute bin bash.
Maybe just
How about,
shell. Yeah.
yeah, bin s, oh yeah, it's Alpine. There we go. Okay, so our readiness probe was to cat temp healthy, and that appears to work. Echo dollar question mark. We get a 0, which is success. So if we were to, in fact, since I'm doing this live, let's open a second terminal. Let's put this down below. And let's do kube control get pods dash L app equals readiness deployment dash W to watch. Cool. Okay, so let's delete temp healthy. So what we should see is one of these, the one that I exec'd into, is now no longer healthy. So it's no longer ready. Now, it's a readiness probe, so we're not going to see the pod restart. The pod's just going to sit there. But if this were a pod that was part of a service that should be taking traffic, then it would go away. Like this would no longer take any traffic. Once the pod was ready again, let's say, for example, the work had been processed and we're ready to take our next round of work, then we can pass the readiness probe again, and you see we're now ready again. So we would start taking traffic again. Sound cool? Any questions in the chat?
Sorry, I was talking, and of course I was on mute. But I was just saying that that's really awesome. And one thing with the liveness probes is you don't have to. Going back to liveness, I know we're on readiness right now, but we were doing like basically an exec where we were just running a curl, but there's an HTTP liveness probe. So using Kubernetes native syntax, I can define an HTTP endpoint and just say here's the port, here's the path, and then it'll take care of it. Oh, we're doing that
Yeah.
here. Oh, cool.
Yeah, we're doing that here. We could be execing and we could be, executing curl inside the container if we wanted to go that route. But because this is a little bit more native, then we went ahead and went with the HTTP option instead.
Yeah, and maybe if you don't have an HTTP exposed service, so the way you would do a health check would be to exec into the container, maybe run a health check script or check something against your service locally in the container.
Yeah, I've seen all kinds of stuff. Like, has the log file been updated recently? I'm not a fan of logging to a file in a container, so I wouldn't necessarily want to do that. But you can usually find a way to exec into the container and execute whatever you think is necessary when you need that advanced level logic to figure out if you're ready or not. And short of that, if you're just talking about an API or something like that, just build an HTTP endpoint. Like make a /health for answering that kind of question, and then just have the orchestrator check it. So that's definitely the preferred way to go. Okay, so we've done the bits that are in the workshop. I thought it could be kind of cool to then go ahead and work this into our actual demo application. What do you think? Should we do that live?
You know, I always say we do it live.
Yeah, definitely. All right, so I'm bound to mess this up. So just don't laugh at me too hard. What I'm going to do right now is clean up our demo apps, our liveness and readiness stuff, and then let's go and we'll modify the Helm charts for our existing Node.js app, and then we'll deploy that and we'll start messing with it and we'll see what happens there.
And hey, Brent, for those who maybe haven't seen the videos from last week, what's Helm?
Oh, yes. So Helm is a templating engine that we can use to deploy our application. And the reason I wouldn't have to use it today because I'm not changing many things over and over. That's when templating is really handy. Um, but I do have one chart that I can deploy all, and it would, deploy out all three of my microservices together. So I like using the Helm chart for that because then I'm not doing, three deployments and scaling and all that. That like the workshop walks you through, starting from zero and doing a basic deployment, and I don't have to necessarily start there. So yeah, that's why I like using Helm in this particular circumstance. Also, I can roll back if I mess something up, so that's kind of handy too. So definitely check out the video from last week where we talked about Helm. I think it's good to know. It's definitely good to work into your workflow.
Thanks for that. And just for everybody watching, if I put it in the chat as well, but if you have any questions, please feel free to send it in chat, and we will do our best to answer them.
Totally. Okay, so for us to be able to modify our Helm chart, we have the Helm chart stored under EKS demo. This is like it is in the workshop, like it was in the video last week. So we're just going to modify what's here already. We're going to modify the Node.js.yaml service. We're not going to do this to all the services, but we will, just go ahead and add this into our node service and use that as our demo. So let's start off building the liveness probe. So the important part of what we did in our demonstration was right here in our pod definition. And it was defining the liveness probe and how to check Node.js. So all we really need to do is add that in to our existing pod or our existing Node.js definition. And it looks like I need to indent more appropriately. It's actually, it's kind of close. Let's go like this. I think that gets it. Does that look right, Adam?
That looks right. Yeah. If not, we'll be told very soon.
That's true, yeah. Cool. Okay, so save :W. By the way, I'm using Cloud9, and I have the Vim key bindings enabled. So :W for save. You could also do Command S to save, or whatever the Windows keyboard equivalent of that is. I don't know what it is.
Control, I think. I don't know.
Control S. That does sound right. Yeah.
I think.
Okay, so we have that defined. Let's do get pods, and let's just stick with get pods. I think we have a -W to watch that. we have a small enough number of pods that they should be able to fit here. So up here, let's upgrade Helm upgrade the app called Workshop, where the chart is located at EKS demo, the directory. Done. And you can see down below, we've started creating containers and terminating other containers. And as our new containers go healthy, our old containers continue to be terminated. And that now is kind of difficult to read and understand what's happening. So we'll get a fresh get pods. In fact, you know what I like to do? Watch dash in1 dash, I won't highlight differences. We'll just leave it like this and we'll see if that works for us a little bit better. Okay, cool. So you can see that we now have new Node.js pods running. And if let's just grab one pod ID, cube control, describe this pod. We'll pipe that to list so that we can see what's happening. Oh, describe pod. My bad. I think I said the word, but didn't actually type it.
Bingo.
Okay. So let's look for the health information. Liveness, right here. And you can see that we're doing an HTTP GET, port 3000/health. Timeout is 1 second, period is every 10 seconds, and we'll be considered successful if we've passed 1. We'll be considered failed if we've failed 3 times in a row. And by the way, multiply that out. That means it's going to be 30 seconds of failure before this particular pod gets taken out of receiving traffic and gets taken out of or gets cycled. It may get taken out of receiving traffic earlier, maybe even on the first failure. I'm not sure about that. We should check the documentation for that. But it won't get cycled until it's failed 3 times in a row. And given that we're checking every 10 seconds, that would, multiply out to 30 seconds. So let's actually test that. Remember, we kube control exec, right? So kube control exec -ti into our pod ID, and we want to execute bin bash. And we killed process ID 1, right? So if we PS, process ID 1 is our node process. So kill PID 1. By the way, down below, you see our Node.js. We're in the first of those 3 Node.js ones. Kill -9, 1. I don't know. Did I kill? I must not have killed it.
Is it? Can you do a P kill? No. P kill -9.
Kill. Let's do p grep -f node. P kill -9 node. PS. Oh, this is weird. Okay, well, we'll go back and we'll do it the workshop way. Health checks. Introduce a failure. Kube control exec.
Okay.
Then killed. Oh, I sent it sig user 1. And I think the regular kill is 15. So kill -s1 PID 1. Huh. All right, fine.
We'll do it this way. The service doesn't want to die.
Right?
You have built the most resilient application.
What is going on? Okay, so kube control exec. Uh, Maybe it's because I'm shelled into it. And if we describe pod, liveness, oh yeah, logs down at the bottom, unhealthy,
There we go.
yeah, and it will be restarted. It must have been because I was shelled into it.
Yeah.
Now I know. So do things live, but don't do things that live. Are we going to see it restart? It's going to take 30 seconds.
I see one restart.
Oh, yeah, that's right. I was kind of expecting this pod to roll completely, but you're right. It just restarted it. And so that's right. Liveness, there's our unhealthy. There's, it will be restarted. And then we saw pull, success, create, start. And now it's back up and running again. And you're right. There's our one restart for that one pod.
And I just want you to know, now that the chat is really up in arms over the Kill Dash 9 not working, I, I think we're all just a little bit confused and trying to find a resolution here. So
Yeah, totally. Well, I know that if I were to kill it outside of the container, it would have worked. But I was trying to do it inside the container, and I'm sure that that definitely is playing a role. Okay, let's move on to the readiness probe. Now, the way we were doing it in this particular example is we were using the Alpine image and we were executing a cat command basically. Um, I'm not I'm not a huge fan of doing that for a health check because really what we're trying to find out is does this file exist is really what the check was all about. There's a better command for that, so they use the better command. So in our Node.js YAML, let's add on a readiness probe. I'll just put it below the liveness probe. And instead of cat, I'm going to do um, test, and I'm going to do -f to see if there's a file. And I don't have that temp healthy thing, but the same idea can happen with readme.md. I know that this, I just copied over. Let's confirm real quick. If I cube control exec, we'll just terrorize this one pod. Cube control exec -ti bin bash. So basically, the work directory is user source app automatically, and my application included a readme.md. So I know that file's in there, and I'm going to do test-f readme. If you don't know, test-f says, does this exist, and is it a regular file? There's no output, but you can see success. And if I were to instead do readme.md doesn't exist, then that would fail. So it does not exist. It is not a regular file. So my readiness probe is going to be that this file exists or not, right? So did I save that? Let's save again just in case. :W. And now let's upgrade. Cool. We have things churning.
there it is.
And by the way, while this is happening, you can still see that, our application continues to take traffic and still serving successfully. It's all good, right? So we're rolling out our new deployment. We're deleting our old pods now. So let's start messing with our new one. I'm going to grab this first pod again, and let's just exec into it. Okie dokie. So the whole test is, does readme.md exist, and is it a file, right? So in one of these, what's going to happen, remember, this is the readiness test. So what we should see is the Node.js line. Right now, you see that we're sending traffic to availability zone A. You'll see B pop up from time to time, and you'll see C pop up from time to time. So we're hitting all three availability zones. When I make one of these pods not ready, then one of these availability zones is going to fall out. It's not going to receive any traffic anymore. So we can make it not ready by, let's just rename README to readme.md.disabled. And we should then see one of these pods, the top one, should go not ready anytime. This check happens every few seconds. If I describe, oh, I'm in the pod, so I can't describe.
Maybe get out and do a describe.
Well,
Oh,
yeah,
there we
maybe
go.
so.
Nope.
But yeah, you see that it's not ready anymore. I don't know what availability zone that was, so now let's just take a quick look, and we see AZA and AZC, but we're not hitting AZB. So we're not sending traffic to the not ready pod, right? Now it's going to stay running. It's still considered healthy, but it's not considered ready. So until it's ready, it's not going to receive any traffic. Let's actually do this to another pod just to make it much easier to see. That way we're not bouncing traffic around. Let's kube control exec -ti, a second pod, then
And
bash.
Brent, a question came in. I think it's a really good question. Um,
Yeah.
so, if it's an API workload, doesn't it make sense to hit a live endpoint instead of checking for a file?
Oh, totally. The live endpoint still, well, it depends. So, what is the, like, for this particular thing, this example is, it's not a great example of not being ready because, my API really isn't in the middle of doing a bunch of work, right? But let's say that I have an API that until it has completed its work, it can't respond to any additional work. I don't know how, if there's an API call for that, then great. I that would certainly be a good way to handle it. But if there's not, if it's check for the existence of a file, or if it's, just any command that you might run like on the command line, maybe if it's Rails, maybe you're, executing some Rails type query to figure out if you're available to take work or not. Um, I'm just trying to show that you can execute almost any kind of arbitrary logic by executing something inside the container. But yeah, you could totally make this an HTTP call instead. And then you could even build that logic into your app and make it, instead of /health, make it like slash or am I ready? And return whatever the appropriate code is based on whether you're ready or not.
Yeah, and I mean, it even makes sense that maybe your liveness probe is checking an HTTP endpoint, but your readiness probe, as you said, it's a Rails app. You want to run a Rails command, so that may be the two, differences. But I agree. I would love to just, if I have an API, let's expose both to an API and do it that
Yeah,
way.
exactly. So the point is, you're not limited to HTTP. Not saying that it should be this way or should be that way, but you definitely have options at your disposal. So I've disabled, or only one of my Node.js APIs is ready. So that's the only one right now taking traffic. And you see the two additional, or the two Node.js apps in the other availability zones. Those are not ready, so they are not taking traffic. So let's fix that. Let's move README back to its original name, and then exec into the other one. Move that back into its original name. And as soon as those go healthy again, which one of them already had, now they both have, or I shouldn't have said healthy, I should have said ready, then you'll see the traffic start to go back and hit all of the availability zones. So we see C and B, and there's A. So yeah, we're fully recovered at this point. Right on. What other questions are there? Any other questions about health checks?
I don't see anything else in the chat. Questions wise.
Okay, cool. So let's recap real quick. We have just very broadly the theory of health checks, or the practice of health checking. You should definitely build it into your application. We talked about depth of health checking. How deep should you check, and should you go unhealthy if you have a dependency that isn't healthy? No, you shouldn't. You should keep your health check shallow, and then health check each level for all of your dependencies instead. And that doesn't mean that you shouldn't have a check that does all of your dependencies if you want, but don't tie that to your orchestrator and have your orchestrator execute things based on the results of that check. And then we talked about Kubernetes specifics, liveness probes. That's the traditional idea of a health check, which if you fail it, restart the pod. And then readiness probes. And if you fail that, then don't restart the pod, but stop sending traffic to the pod. There is a third kind of health check. Let's check the documentation because I'm slipping my mind.
Startup probe.
Startup probe, yes. So the startup probe is used in the initial startup phase of the pod. So something that might be like slow to start, it's up, but we need to give it a few seconds to get fully started. So don't kill it because it hasn't gone healthy yet. That's where you can use a startup probe. So if you have like Java or something that's really slow to start and initialize and get going, or my Rails app, frankly, is slow to start.
Yeah.
So ping, that's the noob's health check. Yeah, I've definitely seen my fair share of ping as a health check. Don't do that. There is like NC netcat. I've seen like like exec into the container and then netcat whatever your port that you're listening on, port 3000, and just verify that you can make a connection. I've seen that. That's like one level better than a ping. I don't even know if I have netcat in.
Yeah, I mean, ping, unless your service is running on ICMP, you're running an ICMP based service, I'm not sure it makes much
Yeah.
sense.
So like you could totally, I don't know, how do you make this? You'd have to explore to see how netcat would like release. But yeah, like
Z dash Z VZ.
VZ.
Yeah.
Thank you. Yeah. So you could totally health check based on this, and you see how. But if it's, the wrong port, it would fail. So that would. Oh, thank you,
Oh.
Denny 11111. Whatever.
Thank you.
Yes. Thank you. Um, yeah, so definitely, get creative if you want. But I still say use the built-in stuff if you can. Make it HTTP if you can. That's definitely going to be a little bit more sophisticated than usual. And you can also do some kind of cool things like curl. I don't know if I did this or not. Slash health. So like my health check, uh, not only does it return the right code, so if I curl dash v, we get a 200, but it also then spits out the uptime. So I can actually see how long has this process been up if I look at it manually. So you can put in like additional output that you might find useful for exploring the healthiness of your application. Some people like to put in the git commit or the version or the tag ID that's currently deployed, and that's how they can see what version am I looking at right now. That's certainly a cool thing to do. But really, getting back 200 is the only thing that matters. So that's what the orchestrator is looking for.
Yep. And so there was another question
Yeah.
from the Shatterpoint around any intentions of going over Istio anytime. So,
Well, hmm. I I think we could go over app mesh pretty easily. I'm not sure. We could go over Istio if you think that would be valuable. I'd love to get some feedback and find out, are you interested in mesh, just the topic of mesh, or Istio specifically? And if it's Istio specifically, what I'd really like to do is probably get someone that's more of an Istio expert than I am, get them on the show and have them walk us through Istio. But short of that, if we wanted to just talk about mesh and what the pros and cons of using a meshifying your application is, I could certainly do that with app mesh, and that's frankly that's the direction I would go today.
yeah.
So let me know, give me some feedback in chat, what your preference would be, and not just you, but everyone that might be interested in that.
Yeah, I think as we continue to build out the show and look for content, we definitely want to talk about what you folks want to hear about. So
Yeah, absolutely. So, a little bit about the show. We're going to start hopping around various topics. So, each day is going to be a different topic. Today was health checks. Um, Tomorrow, we will get into auto scaling. And we're going to look at auto scaling both our application, our cluster, um, on Kubernetes. But then after that, we're gonna really start to hop around, and we're gonna look at all kinds of different topics, from the basics of using Docker to some of the more advanced functionality with EKS to some really cool stuff that ECS brings to the table. So let us know. Tweet at us. By the way, if you, Adam, if you want to throw our Twitter back up on the screen, send us tweets, tweet at us, let us know what you'd like to hear us talking about. We'd be glad to add that into the mix. We're going to be here Monday through Thursday, uh, the same hour every single day. So if you're West Coast, it'll be the noon hour. Hopefully that makes for a good lunch and learn. If you're East Coast, it'll be the 3 o'clock hour. So hopefully you can take a break out of your day and tune in. And otherwise, we just want to talk about containers and talk about the things that the obstacles people are running into and how to get past them.
yeah, yeah, that's well said. It looks
Cool.
like security and networking. Yeah, absolutely. I think those are
Yeah,
definitely topics we can dive into.
definitely. In fact, I would even say so. We have a another counterpart named Pavan. and we hope to get him on soon. He's in the middle of a move, an international move, so he hasn't been able to join us yet. But he loves to talk about security. So, that's probably going to be all he ever talks about once he does join the show. Uh, Pavan, if you're listening, don't be offended. Those are all good things.
He's just
So
really good at it. Like he's
he
just
is.
it's like it's so natural when he talks about it. It's like it's his own language. It's unbelievable. So
Yeah,
he's yeah.
absolutely. So definitely watch for blog posts from Pavan and watch for him joining the show. Hopefully sometime next week. If he can get moved in and get internet access set up in time, then we'll try and work him into the show next week and get him talking about security. He already has some ideas in mind. So yeah, tune in for that for sure. We're going to talk about ECR some. We're going to talk about some really cool stuff that'll be coming out, on that front. And then, we're always going to be demoing stuff, and we're always going to be just trying stuff out live and asking for your help with, the right switches to use for random commands on the shell. So you can tell this isn't 100% scripted or anything like that. So definitely join in, help us out, and then throw your ideas our way. Right now, Twitter is the best way for that, and then we will definitely try and come up with an even better way for to gather your feedback.
Yeah, definitely.
All right. I think that's it. So today we went over health checks. We talked about, just the basics of health checking. We talked about how to do liveness probes in Kubernetes, how to do readiness probes. We demoed it, and then we even integrated it into our existing application. So come back tomorrow, and we'll talk about scaling.
Awesome. Thanks so much, everybody. We will see you tomorrow, same time, same place.
Cool. See ya.